Mrs. Hales here with a science lesson. A what, Miss Hales? A science lesson. Sometimes art and science collide. In school, sometimes we teach things separately just because that's how they fit into our schedule. But oftentimes, subjects overlap. For example, the Impressionists studied light. They studied light on water, light on buildings, light at different times of the day. And they were the first kind of group of artists to paint the same building or the same landscape over and over again at different times of day in different light. And so they tried to capture that in their paintings. Another example of where science and art interact is the study of color. So the way that we perceive color has to do with wavelengths of light energy and how our eye reads that. I'm going to show you a short video that is going to explain how color and light interact, and then we'll walk through each of the parts step by step together.
Light. It's all around us. But what is it? Where does it come from? And what does light have to do with color? Light is a kind of energy that travels in waves. It is made when matter is heated up or gains energy. Excess energy is released, in part, as light. This energy is called electromagnetic radiation. When we talk about light, we usually mean visible light, which is the light that we can see with our eyes. But there are more types of electromagnetic radiation that are invisible to us, including radio waves, microwaves, X-rays, and gamma rays. Scientists can detect and measure invisible radiation with special tools. Together with visible light, all these types of radiation are called the electromagnetic spectrum. All electromagnetic radiation travels in waves, but different types have different wavelengths. The wavelength of electromagnetic radiation, or light, is connected to how much energy it has. Light with a longer wavelength, like radio waves, has less energy, while light with a shorter wavelength, like gamma rays, has more energy. Visible light makes up only a tiny part of the electromagnetic spectrum, but it includes every color we can see. The most important source of light here on Earth is the sun. We call ordinary sunlight white light, but it actually includes all the colors of visible light. These colors can be revealed when white light goes through a prism. When light passes through a prism or something like it, it slows down a little bit and bends. Some parts of the light slow more than others, and the light spreads out into the colors of the spectrum. If you want to see all of the colors in the visible light spectrum, look no further than a rainbow. Rainbows are made when water droplets in the air bend sunlight much like a prism. Usually when we talk about a rainbow, we say it is made of 7 colors: red, orange, yellow, green, blue, indigo, and violet. Each color has a different wavelength. Red has the longest wavelength in the spectrum of visible light, and violet has the shortest wavelength. All the other colors have wavelengths in between the two. The colors of a rainbow are always in the same order, because the colors are arranged according to their wavelengths. Red is always on the outside, because red has the longest wavelength, and violet is always on the inside, because violet has the shortest wavelength. Electromagnetic radiation with a wavelength outside the visible light spectrum is invisible to our eyes. Light with a longer wavelength than the reddest red our eyes can see is called infrared light. Light with a shorter wavelength than the most violet violet we can see is called ultraviolet. When we look at an object, we are actually seeing the light that is bouncing off of it. A green leaf looks green because the leaf absorbs all of the colors in the spectrum except for green, which it reflects. When the green light enters our eyes, our brain tells us it looks green. Things that look white are reflecting almost all of the visible light shining on them, and things that look black are absorbing almost all of the visible light shining on them. Light, both visible and invisible, is all around us. It travels from its source as a wave, bringing energy with it. Without light, there would be no colors. Take a look at the world around you and remember, everything you can see is just different wavelengths of reflected light. Goodbye till next time.
All right, let's dive a little bit deeper into some of those topics that were covered on the video. Another word for light energy is radiant energy. Light energy and radiant energy are electromagnetic. That just means they have magnetism and they have electric particles. Light energy, or visible light, is the only kind of electromagnetic radiation that human beings can see with their eyes. So if you look up here on my diagram, you can see there are lots of different kinds of electromagnetic radiation. Gamma rays, X-rays. X-rays are what you have to get when you break your arm. There's ultraviolet light, there's visible radiation or visible light, infrared, microwave, and radio. We all know what microwaves and radios are. Those forms of electromagnetic radiation just can't be seen with the eye. And so if we look at the wavy line of visible light on the bottom, you can see that the red wavelengths are longer than the violet or the purple wavelengths. So microwaves and X-rays are invisible radiant energy or radiant light, and rainbows and color are visible radiant energy or radiant light. When you're in kindergarten and first grade and you're learning about color and you learn the colors of the rainbow, stand for Roy G. Biv: red, orange, yellow, green, blue, indigo, violet. Those go in order of the wavelengths. So red is the longest and violet is the shortest. So what things produce radiant energy, or where do we get radiant energy? Think about it. The sun, light bulbs, lasers, fire, but also the moon and the stars produce visible light that we can see. Light waves move super fast. They are the fastest moving particle that scientists have discovered. That's why when we're having a thunderstorm, sometimes you'll hear the thunder after you see the lightning. They actually started at the same time, but we see the lightning first because the speed of light moves faster than the speed of sound. Electromagnetic waves or light waves are transverse waves. That means they have a high and a low, or a crest and a trough, that travel in a straight line. Wavelengths are measured from crest to crest or trough to trough. Now, what happens when that straight beam or straight path of the light comes in contact with something like matter? So like a building or water. Well, the light has to either be absorbed by it, move around it, or move through it. When light waves bounce off of a hard surface, like a mirror or a mountain range, that light is reflected back at the person so you can see it. In this case, the water is reflecting the light waves. This is one form of light that the Impressionist painters were trying to capture. Light can be absorbed by matter. So on a hot day, asphalt, like a road or a sandy beach, will absorb that light and create heat. Plants also absorb light. And through photosynthesis, this is what enables plants to grow. Radiant energy or light energy can also be collected and stored for later use. Can you think of anything that technology today is allowing us to do this with? So is there anything that collects the sun's energy and stores it and transforms it for humans to use later? I think all of the solar power, the solar panels that you see, that's what those do. Light waves can also bend as they move from one type of matter into another. So in this case, when they move through air, which we can see through, and the water, which we can also see through, we can tell that these light waves bend. And we can see this because the straw looks like it's bent. Why does this happen? It happens because light moves at different speeds through different types of matter. If you've ever seen light hitting a crystal that's been cut or a prism, and you see how it bends the light and kind of moves it around, that's another example of refraction. Sir Isaac Newton, the same guy who discovered gravity, did a lot of work with prisms and refraction and the color spectrum. And he is actually credited for giving us or inventing the color wheel. Another way that matter influences the way light travels is that it can transmit light. So in this example, this window is allowing light to come through or be transmitted through glass. Light can pass through some materials really easily, like plastic wrap and clear glass windows. That is called transparency. It passes through some materials just a little bit. That is called translucency or translucent. Can you think of anything that light passes through just a little bit? So it's not totally clear, but you can tell there's light out there. Maybe something from your house or something in your kitchen. So wax paper from your kitchen is translucent. Pantyhose are translucent. Copy paper is translucent. If you if you want to copy an image, you put your picture up on a window and then you put another piece of white paper on top of that and you can trace. That's, that copy paper is translucent. Something else that we use in the art room that is translucent is watercolor paint. So you can layer the colors of paint and sometimes you can see what color was underneath, or you can at least tell that there was another color underneath. And watercolor painters use this layering ability and the translucent quality of the paint to make their paintings richer and more realistic. When an object is opaque, no light can travel through it at all or pass through it at all. So I always think of like a building made out of steel or wood. That building is opaque. A piece of black construction paper is opaque. No light is going to get through that. So opaque things like a building or you walking down the street, interrupting or blocking that straight beam or ray of light, that is when a shadow is cast, when something opaque blocks that beam of light. All right, you smart, informed scientists and artists, now we're going to do a quick review. Light is a form of energy. It's true, light is a form of visible radiant energy. Light travels in a straight line. This is also true. Light travels in a straight, wavy line. Light passes through opaque materials. This is false. Opaque materials are solid matter that light does not pass through. But opaque materials can absorb light. Light passes through transparent materials. This is true. Light passes through glass and plastic wrap. Some light can pass through translucent materials. This is also true. Materials like copy paper, tissue paper, pantyhose allow some light to filter through. Light is best reflected off smooth, dense, or even, I would add, shiny objects. This is true. Think about a mirror or water reflecting a mountain range. You're almost done, boys and girls. Just 4 more questions. Light is best reflected off soft, bumpy objects. This has to be false because you just told me light reflects best off smooth, dense, or shiny objects above. Light can be bent. This is true. We saw this in the straw in the glass of water. Light travels the same through a gas and a liquid. This is false. Light travels at different speeds through different matter. All colors are present in white light. This is true. All the colors of the spectrum are present when something is white. So then the opposite would be true. When something is black, that's the absence of color or no color. 5th graders, I hope you enjoyed learning about color and light, and I'll see you next time back in art class.